So today we're going to be just looking at how to use your graphing calculator to solve questions. And that is going to be mostly how to use it to integrate or to find the derivative of something. And you can only do that if you have specific points or bounds that you're looking at. Graphing will also be handy. So if you have to find a minimum or a maximum, you can do that using your graphing calculator. Now, part of the problem is if you just go off graphing, sometimes you won't be able to see the graph. So I've got my virtual TI83 pulled up here, which I've posted online. So if you don't have yours or you want to use the virtual version, you can. Um, the virtual version kind of stinks. It's, as you can see, it's very grainy and pixely and stuff, and it's a lot more tedious to use a mouse than to actually push the buttons with your fingers. But if you don't have yours handy, then you can use the virtual version. So if I hit graph, you'll see that an XY axis pops up, and that's because I haven't actually graphed a function. But you will also notice that I have little dashes along the XY axis, and that's indicating my scale. Now I can change my scale and I can change what I can see here by going into window. If I hit the window button, you'll see that my minimum X value is -10 and my maximum is 10 and my scale is 1. I could change this, for example, to -5 and my max to 5, and I could change my scale to 2. And what would happen is now when I look at my graph, my scale is spaced way farther apart because these dashes are each worth 2. So over to the left would be -2, -4, and I don't have another one because the next would be -6. And I said my minimum was -5. Okay. So when you want to view your screen, okay, what will happen is over at your minimum here, for example, this is your minimum X value. That's the farthest you're going to see to the left. And this corner would represent your minimum Y value. Okay. And when you end up with a grid in the middle with dashes along it, okay, this is going to be your minimum X value. This would be your maximum X value, which here we see is B. This would be your maximum Y value, and this would be your minimum Y value. So your X max here for this question, for example, would be B. Your X minimum would be A. Your Y max would be D. And your Y min would be C. So if I take a look here, for example, this is going to be my max X value. And this would be my max Y value. Okay. And so what that means is we are viewing a grid. They won't show you all your grid lines, but you're viewing a grid that is A to B by C to D. So A to B is your domain of your grid, and C to D is your range of your grid. So for example, if I want to graph a grid with the following windows, your X min here is -2 and your X max is 2 from this first set of square brackets. And your second set of square brackets is representing your Y min and your Y max. And so if I pull up my graphing calculator here, okay, I want to set my minimum here to be -2. If it will let me. See if I work. Oh, there we go. And I want to set my maximum. Oh, it's because I used the minus button instead of the negative button. So what happened there was I used this minus button instead of the negative button. So I need -2 by 2. I'm going to change my scale back to 1. And then my minimum for my Y is also -2 and 2. And I'll keep my scale at 1. Now, where you're going to enter the function you want to graph is over here on the Y equals section. So you're going to click Y equals. And above this blue apps button, there's an XT theta N button. That is your X. That's where you're going to enter your variable. On the screen, no matter what variable your question has, it will always be an X. So even if you're dealing with a theta, when you input it into the calculator, it's going to input it as X. So if it helps you, you can just change all your variables to X when you're doing a question that you need to input. You can write that down on your page if that's helpful. So I'm going to make X, and then I've got a squared button, and then +4. I like to hit enter. I don't know why. You don't actually need to. So you've changed your window. You've put your function in y equals, and then you're going to hit graph. So you can see I've got -2, -1, 1, and 2 here. Now, why can I not see anything? Well, I can't see anything because if I think about what this thing actually looks like, this is a parabola with a y-intercept of 4. But my maximum y value is 2. So my entire parabola is off the screen. Okay. So this is a parabola with y-intercept 4, and it opens up. So what I just saw on my screen was this. So if I take a look at my x min, x max, that's because this is -1, and technically -2 is right on the edge of the screen. This is +1, +2 is on the edge of the screen. This would be 1 and -1 for a y value. And this is why I can't see anything. So if you're graphing things and you can't see a graph, you might need to change your window. So for example, again, if I look at the first set of square brackets, this is my domain. So my domain is now going to be -6 to 6. My range is the second set, also going to be -6 to 6. And so all we're going to do is we're going to go in and change our window here. So if I click window, I'm going to change this to be -6 and 6. And my minimum here will be -6 and 6. And I don't need to go back into y equals. It will save that function for you until you delete it. So I can just go and re-hit graph. Now you see there's a lot more lines there. And that's because this is now 1, 2, 3, 4, 5, 6. Is my scale is 1 still. And I go up to 6. And now I can see the parabola. So if I want to draw this in, now this is 1, 2, 3, 4, 5, 6. And I've got the same over here. So this would be -2, -4, -6. Okay, so all my axes are worth 1 here, and I have a parabola that has my intercept at 4 and goes up like this off my screen. It's a lot easier to see what's going on. If I changed my scale, what would happen is I wouldn't have this many dashes on my axes. I would just see some of my dashes. So if I change my scale to 2, I would only have every other dash along both the x and y, depending on where I change my scale. So for example, if I want to graph this function with the graphing calculator, find the domain and range and use it to get the appropriate window. So first, if it is a radical, we know that our range is y is greater than or equal to 0. Our domain, we know that 0.1x plus 20 must be greater than or equal to 0, or 0.1x must be greater than or equal to -20, or x must be greater than or equal to -200. So in order to see this whole picture, I need to make sure that my range, my minimum could be 0, but then that means the bottom part of my screen is going to be the axis. So I'm probably going to choose a range. So I'm going to use this to choose a y minimum as I'm going to say y equals -1, just so it's a little bit less. Okay. And then also we know that our x is greater than -200. So I don't want my minimum x to be like 0. I might want my minimum X to be maybe negative 202 or something, just so I can see enough. If I'm using something as big as 200, 202 is probably going to be too negligible. I might want to choose something like 220 or something. So I want to choose an X min smaller than this number so that I can make sure I can see the entire graph. So I might choose, maybe I'm going to choose negative 220, and then my max, maybe I'll go up to like 100. And then my Y minimum, maybe I'll choose -1 or -2 or something. And then maybe I'll go up to something like 20. So if I do that, if I go into my graphing calculator, to clear the graph, I'm just going to hit the button clear. Under Y equals, I'm going to clear that function. Square root is hidden behind the x squared, so I need to do second and then the x squared button, and then I'm going to do 0.1. Use that x above the apps, plus 20. Close your bracket. Move over to window. I'm going to make this negative 220. I'm going to make my max 100, and I'm going to make my scale 10. Then under X or Y min, I'm going to go -2. I said I was going to go to 20, and I'll make my scale, maybe I'll make my scale 2. And then if I say graph, okay, you can see here that we have a nice little graph going. So we're going to draw this in. It does not need to be exact. You're just sketching so that you can get practice using this window. Okay, that's all. You can add little dash marks and be more specific if you'd like. Okay, so you can see that that's about what that looked like there. All right, so then same thing, if you want the graph to be gone, just hit clear. Now, once you've graphed, you can actually find maximums, minimums, zeros, intersection points between multiple graphs. And we're going to be using to do that, there's this trace button, and hidden behind it is calc. So if I hit second calc, I can calculate a specific value, a zero or an x-intercept, minimum, maximum, intersection. I can calculate the slope at that point, all these fun things. So this is going to be very helpful for us. So this question's asking us to graph x cubed plus 5x squared, and then it's asking us to find the local max and min. So if I just start graphing right now, so again, I'm going to clear my previous one. I'm going to use x cubed, so that means the x. There is no cubed button. You're going to use this little button that looks like a hat underneath the clear button. So that's going to give me to the power of 3 plus 5x squared. And if I say graph, what's going to happen is I can't really see this. I need to fix my window. So I'm going to change my window. I'm going to go back to my standard -10 to 10, my scale of 1. And try that and see if I can see enough information here. Now, so I can see this way better, but I cannot see a maximum. So I need to fix this again. I'm going to change my Y max to be 20 and then see if that helps us. Aha, so now I can see this thing. So let me just graph. So we went from -10 to 10 and then -10 to 20. And this thing is going up over here and something like this. So we know that our local max is right here. And so my job is to try and find this. So my first step here was to graph. My second step was to fix the window. so we can see the local max. Okay. And step 3 is going to be using the calculator to actually find this max. So in your calculator, what you're going to do is you're going to go second and then hit the trace button, and that's going to activate the calc feature. And I'm trying to find a maximum, so I can either scroll down here using these buttons to the maximum and then hit enter, or I can just hit number 4 and it'll select it. Now, what you're going to be doing is when it says left bound, right bound, this means you're eyeballing it. So you're going to move your cursor along the curve to the left until you get up to what you think is the maximum. Then you're going to go just a little bit to the left of that and hit enter. Then you're going to do a right bound. So you're going to go a little to the right of where you think the maximum is and hit enter. And then your guess is going to be somewhere in between. If you're eyeballing it, where does it look like? And hit enter. So you're going to be moving the cursor along the curve left and right using the blue buttons, left and right buttons. And you're going to hit enter after each guess. So one slightly to the left, one slightly to the right, and one where you think it actually is. Hit enter. It's going to think for a little bit. And it tells us the maximum is at an x value of negative 3.333 and a y value of 18.5. So we have a coordinate for our max value. Okay. So what we did is we hit the second button, and then we hit the trace button, and then we scrolled down to maximum, and then we hit enter. Okay. Or you can think of this as these two is the same as doing second to activate calc, which is behind trace. Okay. And here instead, you can just hit the number 4. Because it says 4 maximum. And it'll automatically take you there. Okay. So once you've done that, then you're going to move your cursor to the left of the maximum. Hit enter for your guess of your left guess. Okay. Then move cursor to the right of your maximum. Hit enter. It'll say right bound. Okay. And then move cursor to your guess of where the maximum is and hit enter. And then number 5, the x equals y equals of maximum will appear at the bottom of your screen. Okay, and so for us, max was at negative 3.33, comma 18.52. And that was a local max. Obviously, we also know how to find this using derivatives, but your calculator can help you with that. Okay. Now, if I was asked to find the solution, remember this is the same as saying find the zeros or x-intercepts. Okay, and so again, if I want to graph this thing, I'm going to go back to my y equals, and I'm going to change this. I can rearrange and find my zeros or x-intercepts, or I can graph these two things separately and find where they intersect. Okay, so I can find the zeros or x-intercepts by making the equation equals 0, or I can graph y1 is x cubed, y2 is 4x minus 1, and find intersection point. So if I want to do that, I can in here, I can graph x cubed, and then I can graph 4x minus 1. I'm going to double check my window. That seems reasonable. I can probably change x max back to, or y max back to 10, and I'm going to hit graph. It'll graph one and then the other. Okay. And I can see that there are two areas. And so I can see this one. This one I can kind of see. I might want to change my y minimum just a little bit, make it easier to find. Okay. And so I've got a couple places where these things seem to intersect here. So I have to do this separately for each intersection. So if you want, you can zoom in a little closer here, but and then change it for the middle one, and then change it for the right-hand one, or you can just keep it all in one spot. I'm going to go to second trace or calc again, and this time I'm going to hit number 5 for intersect. Okay. When I do that, it's going to basically have us move along each curve, and then it's going to have us guess. So this one, I'm going to just move along until, okay, this is moving along the cubic. So I'm going to move along until it looks like I'm intersecting. That looks about right. Second curve, this one's going to move along the straight line. So same thing, it looks about there. And then I'm going to guess. So if I don't think I'm in the right spot, I can move it around a little and then hit enter. And then it's going to think, and it tells us one of our intersection points here is 0.25 and 0.016. Okay, so our first one that we found here was 0.25 and 0.016. And what this thing looked like when we graphed it, we've got our cubic, and then we've got one that looks kind of like this. So you can see we've got 3 intersection points here that we're trying to find. So we found the middle one. Okay. Now if we go back, we're going to do this again. We have to hit second calc, hit number 5 for intersect. This time we're going to go up to that top intersection point. That looks like to be the closest I can get. I can go below it or above it. It doesn't matter which one. I'm going to guess, move along the line and see if I can get a better approximation, and then try and guess where it happens and hit enter. And it gives me another point, 1.86 and 6.44. Okay. And one more time, second trace, hit 5 for intersect. We've got to move our cursor down to that bottom one. Okay, and we're going to take a guess. That looks about right. Move our cursor along, figure out where I think I am. And I get negative 2.11 and negative 9.46. And our min and our max here we used negative 10 to 10 and negative 15 to 10. So again, step 1, graph. y1 equals x cubed, y2 equals 4x minus 1. We graph them separately. If you did it the other way, you could rearrange this algebraically and then find zeros. If you wanted to find zeros, you would do second calc or second trace and use number 2 for 0. Okay. So number 2 was adjust window, to see all 3 intersection points. And number 3, okay, we used second, and then we used the trace button. And then we used number 5 for intersect. spell intersect? And then you would either hit the number 5 or you can hit enter. Okay, so this was the calc feature that we're enabling, and this was number 5. And then what you're going to do is for each point of intersection, you will need to do step 3. Okay. And so again, you're going to find along one of the curves, hit enter, along the other curve, hit enter, and then a guess. So now the next one is, well, what if we wanted to find the area underneath a function? Well, we know that an area underneath a function is an integral. For this one, it's from 2 to 5. And this one's going to be cosine x plus 3x dx. Now, this is something we do know how to integrate. We can do this. We could use this to help us confirm our answer, but we do actually have a button on our calculator. Okay, so if I go under my calculator, I'm going to clear my graph. Okay, the math button is going to be our other main button we're using. So the y equals window and graph is what helps us graph something. Second trace is what helps us find something like an intersection point, max, mins, zeros. This math button is the thing that will help us calculate integrals and derivatives. Now, you can only find an integral on your calculator here if you have bounds, and you can only find a derivative if you have the point at which you're finding the derivative. So what we're going to do is we're going to go into math, and then we're going to scroll down until we find the integral. So Fn integral is going to be what helps us integrate. N derivative is what helps us find a derivative. So we want an integral here, so we're going to do this, and you can hit 9 or enter. Okay. So you're going to go to the math button, and then you're going to find the one that's Fn int. Sorry, that's my coffee maker. Okay, that's the number 9. And what you're going to do is the first thing you're going to do is you're going to input your function. So for us, that's cosine x plus 3x. And then the next thing you're going to input in your list is going to be the variable you're using. Okay, your lower bound and your upper bound. And then you're going to hit enter. So what that's going to look like on our screen is Fn int. It gave us a bracket. We're going to input into that cosine x plus 3x. You're going to use a comma and input the variable, which is x, comma, input the 2, comma, 5, end bracket, and then you're going to hit enter. Okay. So we already have on our screen, then we're going to hit cosine x. You're going to have to close that bracket. So actually, I'm going to put brackets around here. If you don't close the bracket, what will happen is the x will also go in here, and so will the x and the 2 and the 5. And then when you're done, it's going to give you an error. So make sure you close this bracket and hit plus 3x. Then there's a comma above the 7. Hit comma. You're using the variable x, comma, lower bound, comma, upper bound, close bracket, enter. It's going to think, and it tells us that this is 29.631. We could also say, we could round that up actually. Let's go back and take a look. It's 0.6317, so I should actually be saying 62. Okay, or 0.63. So the next one is asking us to find f prime of 3. So this means that we actually want the derivative function here. So if I go back into my calculator, back into the math menu, scroll down, you'll see that you have an n derivative. You want to hit that one. So here we're finding the derivative of x at x equals 3. So we the math button. We're going to scroll down till you see n derivative. Okay, this is number 8. Okay. And so this time what we're going to do is on our screen, we're going to have n derivative with a bracket. We're going to put the function in. Then the variable. And then the value that you're evaluating at. So for us, what that's going to look like is it's going to be the square root. So to access square root, again, it's hiding behind the x squared. You're going to hit second and then the x squared. Inside our square root, we have x plus 1. And we're going to close bracket times x squared times cosine 3x. Close the bracket for the cosine 3x. Then you're going to use comma. Variable is x, comma, at 3, close bracket, enter. So what this looks like is square root x plus 1 times x squared times cosine bracket 3x, close bracket, comma, evaluated x, comma, x values 3, end bracket, enter. And this gave us negative 35.2379 or 0.24, or you could do 0.238. And then we're done. That's it. We've got one more that we're going to try. I know this is a long section. It is going to take practice for you guys to get the hang of using your calculator. So reference these notes where you need to help you figure out how to input into your calculator. There's also tons of YouTube videos and stuff online that you can Google how to find a maximum using TI83 or whatnot. But always you can reference this video again, or even just the notes. I've written them all out. So this one, we're trying to determine the x values where we have a local maximum. Okay, so we know that this is f prime and not f. But I want to know, where does f have a local maximum? So I know that f has a local maximum when f prime is equal to 0 and changes from positive to negative. So if I graph this f prime I've been given, I'm going to look for where does f prime equal 0, and it's changing from positive to negative at that point. So my job is to graph f prime. Okay. And I'm going to look for zeros where f prime changes from positive to negative. And then what I can do is I can, in order to find these zeros exactly, I can use that second trace or the calc feature. And then underneath that feature, one of the options is zeros, number 2. So I'm going to graph this thing. I need to go back to y equals. I need to clear the functions I'm not using. I need to enter this one. So I've got 2 sine x plus cosine x. Make sure you're closing your brackets after each trig function. minus 9x squared. If I go to graph, I can't really tell what happens. Now this zoom will also can also help. Some people know how to use it a bit more than others. I'm not super familiar with the zoom function. So if you're interested in that, you can also Google that. So zeros, that's what I'm looking for here. Now I'm trying to find where this thing moves from uh, positive to negative. And I can't really see what's going on. I need to be zoomed in a little more. So I'm going to go maybe from -2 to 2. And I'm going to change this to say 0.25. And I'm going to maybe make this -3 to 3 so that I can just zoom in a little bit more here. So here I can see, okay, I've got a positive to negative and a negative to positive. So the left-hand zero is going from negative to positive. The right-hand one is going from positive to negative. So I want to use that zero. And so if I go to second calc or trace and down to the zero and hit enter, I don't care about the left. I want to know the right one. So I'm going to move along my curve so that I'm just to the left of that zero. And then I'm going to move so that I'm just to the right of that zero. And then I'm going to move to where I think that zero is and hit enter. It's going to think a little bit and see it says that y is 0. If it didn't say y is 0, we definitely did not find the right spot. So when I do that, I have here a 0 at x equals 0.442, where f prime changes from positive to negative, and therefore f has a local max at x equals 0.2. Because remember, this is the graph of f prime, not f. Okay. And again, y is 0. So if I had found the other one, that would be where I would have a local minimum. All right. Now, there is one more feature, which is absolute value. So if you're asked to integrate an absolute value function, which would come in handy for the distance versus displacement questions, inside my math button, if I go over to number, over to the right, you want to do absolute value, go under math and go over to number. And you'll see that there's an absolute value, the ABS with a bracket, that's absolute value. So if I wanted, for example, to say find the absolute value of -5, I can go math, number, absolute value, and I could put in -5 and it will pop out. That's fine. Okay, but I can also do that inside like an integral or a derivative with an entire function. I could put a whole function inside my absolute. Okay, so there's some practice questions on the bottom. Pick some questions and just try them using your calculator. All right.